So again, welcome to the meeting today, this week. Dieter has to leave early. I'm not sure how quickly he has to leave, but we can get into some quick reports soon. I'd just like to say that I think, so it's been another 2 weeks. We can have a Friday social hour / coding session. If people are up for it, stop by and say hi and hack away at some things. Probably be going through some more pull requests and such. Having a drink if you're up for it. I've been doing them around 4 o'clock, so I'll try to keep that again. So if any other quick announcements from anyone? Seeing no hands raised. Go ahead, Dieter.
Yeah, I don't have to leave too early, 8-ish, I think. So yeah, I don't actually have a lot to say. I was in the field yesterday, and I think it was the first time for me since years now. So that was kind of nice, although I was helping with seismic data, so not my domain. They did measure EM. They did measured on Monday dual EM. Has anyone worked with the dual EM? It's like an 8-meter long pipe. Like, I don't know, do you know EM31? It looked to me like EM31, just big brother, much bigger. And they do some resistivity measurements on Thursday, Friday, but I helped with some seismic refraction acquisition, but it was nice. Other than that, I just have quick, I don't know if you have heard of the Swang rendezvous that, yeah, many of you have been with Sean Walker 2 weeks ago or so. So there's another one this Friday with Matteo Ravasi talking about PyLops and QPy to do stuff on GPUs. It's I think it's 4 p.m. UTC, so that should work for you. I think maybe if you're interested. And then Steve just told me that Friday a week he will do with Wesley Banfield and himself, and maybe myself, do some a rendezvous on these recent JavaScript interactive figures with curve node that they implemented. Some chatting about that, how Wesley achieved things and what Steve has in mind to do with curve node. I guess I don't know more. So I just added in the meeting notes these 2 figures I quickly tried, which can now be linked to any curve notebook. And I don't think they have figured out yet how you could have several sliders or drop downs with an easy callback. So it's not quite a drop-in replacement for a EM app. But for simple things, it's already kind of pretty neat because it's, yeah, you don't need to run Binder or anything else. It just works in the web browser.
So is there just a series of, does it just store a series of figures and it essentially selects which one to show?
Yeah, so in the first plot I have here with the half space, so this I simply coded up in JavaScript. So I recoded it because it's just a half space response. So that does actually compute it while you shift the slider. And then in the second one, I just pre-computed it for these 100 resistivities that I have. And then it goes in as a JavaScript callback into the figure. So it's stored in the figure, the results. So I guess if you would do that for a lot of different combinations, then the figure will become very heavy, but so far it's not too bad. Yeah. So yeah, I think it's very early, but I'm sure maybe Steve will polish these things a bit and hopefully make some tutorials. So I think it could be very powerful, particularly for students to, yeah, that they don't even have to start up their own Jupyter or Binder or anything. It doesn't require anything. So if you have time, that would be Friday a week, might be worth if you wait in and ask and see if, yeah.
Does it change the state for everybody, Dieter, or it's just when you see you move the slider? You guys are not seeing that I'm moving the slider, right? It's just
it's for you.
It's your own personal, yeah.
Yeah. Yeah.
Yeah, it's really neat.
Mm-hmm.
That's it from me. And I won't be there on the Friday beer. It's just too late here, 4 o'clock Vancouver time.
I think so. I looked it up that you said it's 4 p.m. The swung rendezvous is 4 p.m. GMT UTC. So I think it's like what, 8 o'clock here, 8 a.m. Pacific time.
That sounds about right. Yeah.
Okay. Cool. Devin, you've got yourself listed next.
Sure. So I talked with Thibaut yesterday, and we have a bit of a game plan to maybe clean up or better organize the static utils. So some things like plotting pseudo sections or reading and writing data to UBC GIF format was sort of not done with maybe say final usage in mind. So we have a couple of redundant functions. We've got a couple things that are actually more general math functions sitting in there that should be moved. So we kind of came up with a plan for what utilities we want to have, what they should be able to do, and to really generalize it for any electrode configuration. So I think I might get started on that in the near future when I've got some gaps in my schedule. And then, yeah, as far as the discretized tutorials, I guess I'm waiting until the implementation of the boundary conditions stuff is finished before I finalize that work. And then I think try to come up with a plan for the next step of the EM1D merge. So I think we're all kind of working on some different stuff right now, but I'd like to come back to it and really iron out the sort of step-by-step process that we need to complete to get that into SimPEG. That's generally what's on my plate.
Okay. Let's do that after we get through all the quick reports then today, if that works.
Sorry?
Yeah, we can like plan out the next steps then after all the quick reports.
Yeah, I didn't have a plan for that, but I'm happy to talk about it.
Okay. Well, I don't think we have anything else on the agenda for today, so if we've got some time, we might as well. So I can go next then. I've gotten all the, if you notice on the YouTube channel, I got to get all the previous meetings up on YouTube. They're all there if you went back and looked through them. So it should be a little bit more streamlined getting the next ones up. I've been going through a bunch of the pull requests on my end, again, just double checking them, trying to get them in the last stages for getting in. Thibaut, now that you're here, do you know if there's anything, other changes that you see that should be made on your PGI branch?
No, it's been it's been stable since like early December, and I'm not touching it anymore. So I think that's the stage that it should be. Yeah. So yeah, it would be good to have like maybe a meeting for all people involved in joint inversion and see how to advance things.
Okay. I think the path forward that we had talked about before was merging the PGI branch in, so we've already got the updated weighting, the updated like beta estimators in there, right? It's already been merged into master. You're muted, Thibaut.
Yeah, the beta estimate is already in there.
Okay.
But then there is also a lot of things about just the name convention to have it, and like organization, like all that type of things that needs to be thought in advance. And maybe, as I say, yeah, maybe we should do a meeting all together at some point.
Okay. Let's get that on the books, and we'll put up a thing on Slack and see if we can get a time then for some people together. Other than that, I've been, going through some PRs. The C++ refine functions for the tree meshes that I've been working on. I've been implementing them, putting them back into the mesh, like refine tree XYZ thing that Dom had worked on before. The function that I have changed the function or changed the results slightly, because so previously the way that Dom had it checking was just you took a cell. If you had like a box, it just checked if the center of the cell was in a box before refining it. Now I have it like check if the box is like if you give it a box, if a cell overlaps that box at any point, then it will refine it. So it gives it a little bit more, makes it a little bit easier to refine it that way, but it just changes the output slightly, especially at the edges. The same kind of thing happens with the ball function, like if you're refining around points. So just again, now it checks if it's actually, if the radial ball overlaps any of the cells to refine it, whereas before it just checked if the center of the cell was there to refine it, which led to a few odd cases at the boundaries. So now it's just a little bit more uniform manner. And that's all I can share as far as SimPEG related things. So can move on. Lindsay?
Yeah, just a quick one. I'll be giving a talk, and I think Joe was on the abstract. I actually forget all who was. I know Dom saw it and a few others. I'll be giving a talk on Tuesday at a SciAm session on open source software. And so just to flag that, I'll send around some slides, hopefully at the latest kind of by early Monday, so that folks can take a look and provide some feedback. So hopefully it'll be a good session.
Cool. So then is there, Shalom, I see you just lifted up here that you don't have any updates. So is there anyone else that has anything they'd like to share for quick reports as we?
Lindsay, that's next Tuesday, right?
Yes, Tuesday in the first week of March, so the 2nd.
Okay, so what time?
It's at the session that I'm in is from 1 till 3 p.m. Mountain. So I guess for you that's what 2 till 4.
Okay. Thank you.
Okay, well, I don't see any other quick reports on here. There's no one else. I think we can go on to a few of those.
Hey, Joe. I sent you I'm still working on the tutorials for the cross gradient joint invariance, and I already sent you the data and the model files to the.
Oh, yep. I'll get them up there.
Yep.
You should be able to look at how we download the other model files in some of the other tutorials.
Yeah.
Okay, there's a download utility that you should be able to use.
Okay.
Once they're up on the bucket. Okay then. Well then I think we can go on to talking about the EM1D. Get a plan of action to kind of bring it in to the next steps. I put a few of my thoughts on the PR there about things that I'd like to see happen to it before it gets merged into master.
Yeah, I took a look at that. That's good. I think the first step to this comes down to the fact that the way that we do our 3D frequency domain stuff and how we want to do all of it is that we organize by frequency and then by receiver location, but the 1D code is doing the opposite. But I think based on the functions that we have, we should be able to reorganize that. So for me, that's the first step is for the organization of the output data vector to be the same for the 1D and the 3D. And that's gonna require some base changes to the simulation class. But once that's done, all of the other stuff that you're proposing, like, using the receiver class structure for 3D and then just kind of adapting that for the 1D, like I think all that stuff becomes very easy afterwards. But I would say that's the first step, is to get the data structure coming out to be the same, the ordering to be the same.
I think it could just be a matter of just doing a first pass on the sources and receivers to figure out which items you need and then calling the function. Like getting the items, you know what I mean? Like loop through all the sources and receivers, figure out what the actual like offsets and frequencies you need are, and then call the function with the proper ordering, and then go back and put them on the sources and receivers. I think that'll probably be the easiest way to do it, also the most efficient way.
Yeah. Yeah, I'm sort of just looking at what's getting fed in and out of these functions. I mean, it kind of seems like in the end, you're feeding in almost like this list of like offset and frequencies. Just so one line is like a particular offset and frequency. So I think you just need to feed it in the right thing, and it just kind of gives you back, like each row is a unique offset and frequency.
Yeah,
so it's a little more complicated than that, but I think you could set it up to do it.
I think that's essentially the way that it ends up working. So
Yeah.
here's a few other things that I had on there. I know we talked about it before, but like I said, the big picture thing, it's like getting the coal and the VRM's maps would be interesting.
Yeah, I know you're really
thing to add,
on that, but
it'll be a lot
but that seems like something that could be added as a different project.
Yeah, I would think so. It's just it's a big picture thing, and let's something try to get in.
Maybe the easiest way is just forget about like a kind of efficiency in the 1D code, because I think that if you directly follow the 3D structure, there are quite a few inefficient steps would happen in the 1D side. Like for instance, like doing a projection and having a separate receiver class for imaginary and real. It's not like necessary for the 1D code, for instance. And also for the offset, like it's actually, for 1D code, you just need a kind of computational reflection coefficient if you got multiple offset. So they're like the current code is designed to optimize that process, but if the goal is actually getting a same, I mean, 1D is like much faster than 3D code. So at this point, we probably forget about the efficiency issue. Just like, okay, let's just follow the 3D code, and maybe later we can revisit that. But if the goal is actually getting the same structure, let's forget about that part and just follow whatever that 3D structure is. Then it's probably very straightforward. Like we just do a dummy, like a run for a simulation. Like, yeah. So let's say, fine, like even if you don't need to, but doing 2 simulations for real and imaginary, it's kind of fine, but we'll sacrifice the computation cost.
Mm-hmm. Like I said, it could be a matter of just, I think the best, like the way of being is just to collect everything that you need first and then run all the simulation. Just collect a list of all the sources and receive, like a list of all the offsets that you need first, and then do the calculations, and then like project it back onto the receivers.
That's probably something we should even think about for the 3D code as well, because there is a bit of inefficiency right now because we have the real and imaginary receivers and we're forming projection matrices for those when we don't need independent ones for both. I'm not suggesting we like solve that with this, but like there's a similar perhaps thought process we need to put in place in the 3D code.
Yeah, I know it had come up when we were talking about the MT stuff as well. Like it doesn't really make sense to have to like recalculate the E and X, like the E and H fields every time you want to get a different component of the conduct or the tensor, right? Impedance tensor. So that needs to be addressed at some point soon.
Yeah, because it sounds like what you have right now is this thing where there's like projection matrices that are the property of the receiver class. Whereas I guess what I've been used to with the UBC GIF code, they just make a global projection matrix from the solution of the fields on edges or nodes or wherever it is that just projects to the data. So then you're not like looping over it every time. So I mean, I guess, yeah, I was kind of surprised that I guess, I don't know if maybe it's the survey class wouldn't house that projection matrix.
I think the idea is that you could have used like multiple, like the same receiver could be used for multiple, sources, because it's like position doesn't necessarily change. I don't know. Like there's a little, it could be improved. It definitely does.
There's some dangerous stuff with that, and I ran into it before where trying to like reuse receivers for certain situations, and I think one situation I ran into was what was it? It was the fact that I think the projection has a dependence on the frequency. Like if you solve for the fields, the electric field on edges, and then you want to get the magnetic field, you would have to, there's like a omega in that, and then that wasn't carried through properly.
Yeah, and I can tell that for tiling, it makes things very complicated because the receivers are basically defined as being a field thing instead of being a spatial thing. And so that means you can have the locations is replicated a bunch of time. I think it would make more sense if it was a receiver was a spatial thing, and then attach methods to project on it. But yeah, it's big rehaul if we're going to do that.
I think it's something that probably be worthwhile, just because it will slow things down in the future.
Yeah, well, I do like Seogi's suggestion not to be obsessed with the like the maximum efficiency. I really like the idea of getting something that's working properly, getting it merged into SimPEG, being able to provide this new tool that we really wanted to, and then definitely go back and try and improve what's happening under the hood, because it's not going to change how the user interface or uses the code, but we definitely would want to improve it later. But I like the idea of just trying to get something that works properly in as soon as possible.
Yeah, that'll definitely be the first step then. And it seems like after we do that, hopefully it'll be a little bit more obvious, like what the change needs to be to make it more efficient.
Yeah.
Couldn't you in the 1D case, because the fields, they are not huge like in 3D, so couldn't you just cache them, and then if an offset, say for an imaginary, it was already stored when we got the real component, so then the imaginary wouldn't recompute it, it would just use the cached result. So with an underscore attribute, and then if it's not set, you store the response, and if it's set, you just take the real or imaginary of that stored response. Because the fields are quite cheap, they are not heavy if you just.
Yeah, I think it'll be efficient if we split it up into like a fields calculation and a like a data prediction side, or the dpred function.
Yeah.
Right. So then, yeah, you'd want to make a fields object that would give you the real and imaginary. You get the response, and then for receivers at that location for that source, you would then project that to the actual data.
Like, kind of project it. You would already have like that location somewhere. It's just a matter of doing the final, combination or the final transform or something at the end.
Yeah, and I think that's something that we
All right, either.
pretty standard that we
All
do
right.
that anyway. So
Pretty standard. So yeah, getting it into the similar form, I think, will help us eye the next more efficient step. The only other thing I'm kind of curious about is where so Seogi and Devin, there's where the known systems thing is, or if it's something that's worthwhile to keep as part of SimPEG or move it somewhere else. So if you guys could give a little quick overview of what is in that file and what it's doing, like what its purpose is, that would help me a lot to understand. Because I just see it as something in there that's like not being used anywhere.
no, it doesn't. Right now, it doesn't fit. Back when the 1D stuff was in its own repository and everything was part of a survey class, that was basically a way to build surveys with known geometries. So if you had like a VTEM system from 2016, you'd have the loop radius, you'd have the waveform, you'd have like a sampling frequency, you just have everything that you needed for how this system works, and you could just say, make me a survey where these are the sounding locations. But when transferring it over to what we have now, those pieces of information don't really sit in the same place. I didn't really want to delete it. It could be useful to have this, but right now I don't really see how it would fit. It would sort of be more a part of like a survey construction utility or something.
Would it be useful for like to have them as like sources that we've defined, or like source waveforms that we've defined?
I thought about doing that, and I didn't get to it. But yeah, I took all the known waveforms and put those in that waveforms .py, and then yeah, I thought this known systems. Well, I'm just making a source which is going to be associated with a receiver, and yeah, the source item could probably carry everything. I just didn't get around to doing it.
Because it seems like it could be useful to me, like if we extended like the current EM sources to have like, oh, this is a VTEM source, or this is a, this is like common sources like that. So it seems like it could be useful and applicable to, to make use of it in the time domain code as well.
Oh, definitely. I think it would be useful, and people are probably going to want to be modeling with those systems, and be easy to make a tutorial for it. And yeah, I mean, I didn't want to get rid of it, but it could be put in sort of a hidden place until we're ready to deal with it. I mean, one consideration is that because we really want to merge the 1D and the 3D stuff to live in the same place, if we add these survey or these source classes for 1D, we also have to ensure that they work for 3D.
Yeah, I think that's reasonable.
So I'm kind of happy if it just kind of like hangs out and is dormant right now, and that it turns into a small project if somebody has the time.
A gut feeling is that they should almost live in a different repo, that we should just be pulling basically JSON files for different things, and we know how to reconstruct the sources. I don't see it in the scope of SimPEG itself, but that's my opinion. Very useful. We should have it, but I don't see it inside.
Yeah, I thought the waveforms would maybe be enough, because I think that is actually a kind of a general utility that people would want to play around with. And then they can, put their own loop radius and frequencies in there. I don't think that's too much of a stretch.
Yeah, and by experience, like pre-recording waveforms, they change every single damn survey. So there's not really much point in like, pre-recording them, but we should have a utils to be able to reform them or like change them easily. I think that would be really nice.
Yeah, we do have that. There's a couple like specific years that we have wave forms for, but then I did put in the ability to kind of alter or make whatever kind of VTEM style waveform or ramp off style waveform. So you can play around with that, and it's pretty well documented in tutorials. Yeah, I guess one useful thing that we can do this, and it is documented, is that you could just bring in an arbitrary waveform. If you had some file that just had all the times and the currents, you'd be able to just make a unique waveform for every single one of your sources. You could do this.
And then it discretizes it for you?
Yeah, I'd have to go look and see the specifics of it, but the machinery is there. I mean, I think
no
for,
discretization.
yeah,
that's the thing, man, is that it's such a complicated beast, right? You need your time channels of data to be able to discretize your time form well, and it's its own project. Like,
I got a couple of ideas to like make it robust. And oh my God, my internet is very slow. Maybe I'm garbling, I guess.
we can still hear you. Yeah.
Oh, perfect. Yeah, because like my screen is actually froze. Like you guys are not moving.
Oh,
So I thought, like,
you're moving really just to like better for us.
Yeah. So like, one thing that I have done for my local 3D code is just computing the step response. So you just do a fine discretization, like that is especially designed for airborne EM specifically. Then that actually usually work well for most of the airborne case. Then once you get the step response, as we do in the 1D code, we just convolve with the whatever waveform that provided. So I'm not sure, like that actually makes the inverse problem quite expensive, but in terms of forward modeling, then you don't have to worry about that time discretization that much. So that could be useful, and like then user don't really need to define what are the time steps, but then like then you can just provide the time channels. Then yeah, so yeah, that's one way. Not sure that's a great way to go, but if you want to make a simpler sort of user input, that could be something that we could consider.
if you were going to go and express the sensitivities for that situation, could you kind of express it as the sensitivities for a step off, and then you'd have some kind of matrix that's like a digital filter that's doing the convolution? You're saying that's expensive, or is that possible?
We don't need a digital filter. We just need a time convolution, which is like a still linear operator. But the hard part, now it's actually, you need to do that convolution for cell by sensitivity by sensitivity values. So it's, it could be, I'm not sure how expensive it is. My expectation, it'll be more expensive than how we are handling now. The general accuracy would be better, and then you don't have to be worried about the time steps, like designing the time step too much. So yeah, it could be an alternative.
Yeah, I actually kind of like that idea.
I feel like at that point you might as well just, compute it in the frequency domain and transform it to what you need.
No, I'm not saying the frequency domain. It's you still work in the time domain, but you just solve the step off problem. So you don't define so then you don't have to define the waveform at the first step. then you just compute the step response and then convolve with the given waveform. And that'll like simplify quite a few things, because actually the hard part of designing time step is both in the waveform as well as the off time, where you got time channels. So by doing so, then you could actually handle that as a similar, like very similar to 1D problem, that you don't really need to worry about how much time step you put it in. Yeah, just an idea.
Yeah, and if you get the time discretization wrong, or you're not familiar with it, it's so easy to screw up and actually not be modeling stuff accurately.
Yeah, correct. So yeah, and doing that every time, it's actually time consuming. So if either we need an automated designer or something like that to make it for us.
My point is that if you're doing convolution, it's always going to be more efficient to just do it in the frequency domain. Like just do the multiplication in the frequency domain. And it's going to be a, it's a n log n Fourier transform and then a multiplication instead of a, an n squared operation.
I can talk to Joe later. People actually didn't choose that way in general. Like even if you look at the UBC work, they ended up using the timed convolution. And my guess is actually there could be some sort of bias happening, like aliasings happening. And if you don't have enough sample and frequency, then in time you can have artifacts. And also, when you're transforming the waveform into frequency, there could be some biases. So I don't know why. And actually, the way that convolution works in time, we're not doing a typical convolution, but we're doing more kind of efficient way than general convolution. So it's actually not that expensive. I could, yeah, if you're interested, I could absolutely talk to you a little bit more about that.
Okay. Okay, then I think we've got at least an idea of where we want to take the EM1D thing forward. Thanks you guys for sticking around. It's not like super interesting or motivating stuff, but it just helps to talk it out. Are there any other things anyone wanted to bring up before we call it a meeting?
Actually, I kind of have one thing. I probably share my. Can I share my screen?
Yeah, I think if we turn our cameras off, then maybe it won't be as hard. Maybe Seogi won't get as choppy.
Can you guys see my screen?
It's coming. There it is.
Yep.
So the problem that I have working on was estimating the depth to the bedrock. And so you can interpret like, okay, if you got AEM section, resistivity section, then you can get a point. Like you can interpret where the basement is. But you got very sparse, so this is the AEM lines here, for instance.
Yep.
There. And the triangles where we got the well data. So we got the well data that kind of penetrates the basement. So we know that depth to the bedrock from the well data. You have the estimation from the AEM data. So you got two different data sets, but the goal is generating a 2D map of where the depth to the bedrock is. So
excuse me, Seogi, can you tell me actually what we're looking at here?
This is depth to the bedrock from so this is the elevation of the bedrock surface that I have estimated.
So you've taken the EM data, you've inverted it, and then you're looking for some contact for a resistive basement.
Correct.
Okay.
So there's you can also write a numerical code to pick that up, and so I picked that up numerically, and then so I got some points from the HAM sounding location. Those are the circles, and the triangles are the contact between basement and sediments from the well data. So we got a bunch of points in space, which represent the depth to the bedrock, depth of the bedrock. Then the goal is finding a surface, 2D surface, that kind of fits both of them. Is that kind of what the goal is? And the points from AM like should have some uncertainty. Well, we need to somehow estimate the uncertainty of that. And also interesting thing about the point data from AM, it's not a point, because like to be seen at that depth from AM means you need some sort of large volume. So you need to consider it as like as volumetric data. So it has some sort of much larger sampling volume. So you can use the smoke ring to have, okay, at like 100-meter depth, it's about a couple 100-meter sampling volume. But then the well data is much more accurate, but it's a point data. So you can, but still like can put some sort of error estimate. Okay, like I got plus minus 5 meter, for instance. So you got point data, but then much more like a large volume of sampling data from AM. Then you can set that up as an inverse problem. So you can like come up with an averaging operator that averages the 2D values at the grid points, and then averaging to an AM point that represent as one depth at a point. And you can also put a bound constraint for the well data. So let's say you got 5 meter plus minus 5 meter, then you can put upper and lower bounds. And you can actually like just use this like whatever the inverse problem that we're using, the exact same inverse problem that we're using, and solve an inverse problem. And what I actually have done, actually, I used the LP norm inversion here. So you can see kind of the sharp boundaries here. Like this is where like there's a kind of like a big slope happening from AM. And you can actually get a 2D map satisfying both well data and AM data. Anyway, so that's usually the stuff that I'm working on, like combining the ground truth data with the geophysical data and using a SimPEG code to set it up as an inverse problem. Thought it might be an interesting problem. Let's see. So yeah, so if you look at that code, it's actually basically the same code that we're using for LP norm inversion. So you just, what you need to do, you just set it up a simple problem class that kind of does an averaging, then you're set. You can actually do this. So I was having fun. I just wanted to share.
Awesome, man. Do you have any? Do you have a seismic line by any chance around there? Be able to check the basement?
No, my check was the well data, and then that was actually quite matching well. So previously what I've done, I just estimate the surface with just the geophysics and compared with the well data and see how that matches. So that was actually pretty good. But there were some points that were not matching. So okay, then how do I adjust that surface? Is okay, I'm going to just assign some uncertainty. Actually, how I did the uncertainty was doing a smooth inversion for the basement, and then a very sparse inversion, like just setting the Px and Pz to 0. So that will give you a very sharp interface. Then difference between that as like an uncertainty. So because like that kind of pushing the boundary. So that if you have at deeper depth, you have a large uncertainty because that will show a pretty large difference between them. And this is actually something that we could consider like it's basically the same idea of GeoSci, right? So if you got a sparse contact points, and what they do, they use some sort of like kriging estimate to interpolate to the surface. So like we can actually do that, but if you don't want to use the GeoSci, like you can actually use the same inverse problem in every iteration, and you update that surface. So suppose you got the well data, and then somehow in the inverse process, you can update the interface also from the geophysics. Then you can put that small inverse problem within the inversion, just update the surface. until we fit the data, or something like that. I think so. I think that's what you were interested at some point. So this could be also a way that you could do, because like using geostatistical approach is always kind of a little bit challenging, because you need to estimate all this like parameters, correlation length, variograms, and actually estimating those parameters is not simple at all. So yeah, actually even like kind of using what we usually do without too much assumption, it's kind of nice. Anyway, just a thought.
And Seogi, do you expect to sort of that surface to actually be fairly rough, or would you expect it to be a fairly smooth? Like, do you have a sense of the geology in that area?
That's something that I'm not 100% sure. And on the northern part where I got lots of well data, I have a pretty high confidence. On the southern part, we don't have that much well data. But as far as I know, there's supposed to be a fault. Okay. So there's that very sharp surface supposed to be a fault, I think. Yes, I've seen a couple of geologic sections that they have provided at some point, and they expect to have some sort of fault. I'm not sure whether it's completely coming from the imagination or they have some sort of ground truth data to prove it. But on the AEM side, it was pretty clear, because the transition was very sharp. So that if you look if I look at the geologic an AEM section, I can actually see clearly oh, there's on one side there's no basement, on the other side there is basement, and there is a transition, which is very sharp. I don't know that transition is supposed to be very sharp, like a very slopey transition or not, but I know there's some sort of discontinuity in between one and other side.
It does definitely look like a faulting block. I'm pretty sure that they would have seen it at the surface, right? If you look at geological map, they will have identified if there was a fault. It's probably going to be offsetted from your basement, right? Because it has an angle and you're looking at it from the top. But yeah, that's cool, man. It looks real.
Well, it's our best. I know that's real.
Hey, so that I was thinking about you the other day. Yeah, we had that code, right? We were using a tanh function to move a surface. It was basically like a heaviside function. Yeah. Does that work in 3D? Do you remember? It was could it work with a 3D mesh? Like a 3D surface? Yeah.
Yep. So
we could morph a blob if we wanted to. If we had a starting sphere or something, we could morph it.
Oh, I see. No, that one was for a 2D surface.
A plane.
Plane. But well, it's just a matter of whether you have a function,
how you define your function.
A function a polygon or polyhedra, then you're set.
Oh, that reminds me, there was something else that I wanted to talk about really quick, or at least bring up. There's still that pull request on discretize about removing properties, I believe. It would really be helpful if people could take a look at it, see if it works as just kind of drop-in replacement for what you've been working on, in your projects, to see if I think it should work as a drop-in replacement, but just check, see if you run into some bugs. It'd be really helpful. And then the next step that I would need forward with that is we need to add a bit more of the little documentation on the classes there, so we can handle it ourselves. Just documentations on the methods and things. So it should be pretty straightforward though to add them in. That would be the next steps to be able to get that branch in. Things like documenting the classes and so on. Other than that, I don't think there's anything else. So I will see most of you guys, or some of you guys, on Friday for some social hours and whatever you want to do. If not, I'll see you all next week. Bye, everyone.
Thanks, guys.
Bye.
And Judge, are you still there?